so much for having me at KCD Islamabad. Today I'll be talking about debugging Kubernetes and container workloads with the superpower of eBPF. I am Qasim. I currently work as a software engineer at Microsoft. I am from Lahore, Pakistan, currently based in Hamburg, Germany. I love to work on open source, containers, and Kubernetes. These days I'm focused on Inspector Gadget. I'm one of the maintainers, kubectl AKS, and I'm owner of one of the core plugin in core DNS called Header plugin. In terms of today's talk, I'll talk about what eBPF is, how to debug containers using eBPF, Inspector Gadget as a tool, Inspector Gadget as a framework, and then talk about contributing to the project. So in order to understand what eBPF is, we need to kind of understand the challenges behind it, right? So we have an application developer that needs a new feature from the Linux kernel to observe his or her app, right? So he goes to a kernel developer and say, can you please add this new feature to the Linux kernel? The kernel developer says, sure, just give me an year to convince the entire community and I'll get back to you. In a year, everything is merged, right? But the application developer still can't do anything about it because the Linux distro, they still haven't rolled it out. So after 5 years, the Linux distros are done, but the application developer says my requirement has changed, right? So this shows we need something a bit more dynamic, right? And that exactly what eBPF is. So eBPF does to the Linux what JavaScript does to HTML, sort of, right? So you are able to inject code into Linux kernel in a sandbox environment at runtime. So imagine that. It's super powerful. And in the example I show on my slide, we have a eBPF program. eBPF is when event driven. So it is waiting for a specific hook point to be triggered, in this case a system call. And when that happens, you can see in the program, we get a context from the kernel, and then we can do anything we want to do with this information, right? If you want to do or understand more with eBPF, you can go to ebpf.io. They have great documentation and cover all the use cases related to this technology. So eBPF is a powerful technology, but it is low level, and to debug containers using that is a challenge itself. To demonstrate, I'll talk about a project called BCC. It is a combination of BPF tracing tools, and they target different Linux components. The feature I'm interested in is called special filtering. It allows to filter using C groups and mount namespaces. Now containers, they are just bunch of namespaces, and if I'm able to filter by mount namespaces, since a mount namespace uniquely identifies a container, I can filter by containers. In terms of the workflow of tool, with this filtering, you first have to create a eBPF map. You can think of eBPF map as a data structure shared between user space and the kernel, and an eBPF program can look into this data structure, read values from there, and then make decisions based on that. In our case, it will look up the mount namespace and then filter events just for a specific container. To showcase that, I have a little demo here. The bottom terminal belongs to a container. The middle one belongs to my host. And I'll start off by creating a map I was talking about. The map needs to be pinned to the path so that when I run my BCC tool, it can actually look up the values that are there in this BPF map and make decisions on that. In this specific case, this map will contain the mount namespace of the containers we are interested in. So I've started the tool, nothing is being printed. I try to spin up a new process and it doesn't really print anything because exec snoop actually looks for new processes on the host, but since we are filtering for a specific mount namespace, nothing is being printed because everything is being filtered out. So in order to confirm that why nothing is being printed, we have to see what's there in the map actually. So we'll go on and use this BPF tool, which is powerful to introspect eBPF programs on your node and also dump actual values. And in this case, we will dump the value in this mount namespace set. And you would see that currently we don't have anything stored into this. And that's why when we create new processes on this host, nothing is being printed. So what we have to do now is actually get the mount namespace of the container and put that into this map. And this mount namespace should be in the format of hex, respect some indiness, and that's it. And then we can just put that into a BPF map, and then we're done. So in order to get this ID for a specific container, I'll go to the my container, use the procfs to find the mount namespace, and we can see we have the mount namespace there. We'll take it, and then we will format it as expected by the map. And in this case, I'll just show you how the value looks like for my indiness. And it's kind of, you can already see how painful it can get just to filter events for a specific container, right? So in this case, I have this value, and I'll just like before, the way we created the map, we'll use the BPF tool, which is super powerful, to actually inject this value into the map that is used for filtering. And as soon as we inject that value into the map, if we create a new process into the container, we should be able to see the events on top terminal. Again, when I do it on the host, nothing happens. But now if I go ahead and do anything in the container, it's there. So that kind of shows how to filter containers. Now the problem with this workflow it is super painful, because you had to by hand write the mount namespace, format it, make sure it's correctly formatted, and then put that into a specific map. There is no, like, if you saw the events, it doesn't mention anything about the container name, so it doesn't have any way to have the information of the container where the event is coming. You have to remember by hand which mount namespace belong to which container. And also in terms of these BCC tools, if you want to run in a Kubernetes environment, you don't know how to distribute them on a specific Kubernetes node. I know it was a lot of magic in the last demo, but that was necessary to showcase what are the challenges of filtering container using eBPF. Now I'll talk about Inspector Gadget, right? So how it simplifies this process. So Inspector Gadget is a collection of eBPF based gadgets to debug and inspect Kubernetes app and resources. It's a CNCF sandbox project. It is currently available as a crew plugin, so you can just do kubectl crew install gadget. You'll get the client for it, and then you can do kubectl gadget deploy to actually install a daemon set in your Kubernetes environment. It is also available to be installed as a CLI tool on your Linux host, so you can then it talks to the local container runtimes, and then you can just debug it without Kubernetes. And it also has an image which can be used with kubectl debug. So that's a different way if just want to target a specific node or something. In order to showcase how the same thing we had done using BCC special filtering, we try to do it with Inspector Gadget. So in this case, we have this IG binary on my node, and I do exactly the same. Just like exec snoop, I have this trace exec, which traces the exec system call. And in this case, is already container aware. You can already see that I'm able to pass a container name. I don't have to create any map, do anything. And the columns itself that you see has a column name container name. So that means we already, it's much more powerful, right? And simpler. And once I start a container, you already see the shell command because a new process was created. And similarly, if I will now cat the result.conf, I will also see the event for that with the container enrichment. So that's kind of Inspector Gadget simplifying stuff for you. And the filtering of the container, like before, is happening in the kernel by the eBPF program. So that's also super powerful. And now if you want to filter only specific commands, you can also do that with our filter feature. So that's also very powerful if you kind of only interested in specific commands or specific PIDs and stuff like that. So again, if I do ls, nothing happens because although it's a new process, but I'm filtering it out. But in case, since I only care about cat, now you can see the events coming from there. So again, this shows how Inspector Gadget simplifies the process of debugging containers in Kubernetes workloads. And while talking about Kubernetes, I'll just do a simple example for Kubernetes as well. So just like I said, I deploy the daemon set onto a Kubernetes cluster. Then I can just run a gadget using kubectl gadget trace exec. And again, you can see I can pass in the name of the pod, and that's it. And then when I create a pod, in my pod, I should see the events up there. So after seeing the demo from Inspector Gadget, we can say that the painful debugging experience is gone. Lack of support of container enrichment and container filtering is also fixed. The packaging distribution, yes, you can ship eBPF gadgets to different nodes using our daemon set, but if you want to write your own or a custom eBPF programs, that's still a bit painful, and that is what I'll talk about in the next section. Inspector Gadget as a framework. So think of it as we want to decouple the idea of gadgets from Inspector Gadget and use the idea of OCI artifacts, just like used by SBOMs and Helm charts already. And the gadgets will be packaged as OCI images and published to OCI registry. So on the right side, you can see I have an OCI registry, and the gadget now is living in the OCI image with a metadata file and an eBPF programs and definition of maps. And the way it is used is similar to Docker. So for example, in case you can build your application as an OCI image, push it to our OCI registry, pull from the registry, and then run a specific gadget. So it's kind of similar UX, and just like Docker Hub, the gadgets are discoverable at Artifact Hub. It's already, we have our own kind there, and you can click there and see what are different gadgets that you can run. And just to say that this feature is under active development, so we're looking for feedback from the community. But the idea here is that now the eBPF programs, they don't need to be married to Inspector Gadget. Inspector Gadget as a daemon set can be deployed. You can just write your custom eBPF programs, build them into OCI images, and just run them. So that kind of simplify the whole process of packaging and deploying your programs into Kubernetes nodes. So now, in order to demonstrate this new image based gadget approach, I'll do a quick demo. So the idea would be that I have some local eBPF program. I'll quickly peek firstly into the metadata file, which is this gadget.yaml, and it contains description about the gadget, information regarding different fields. You can see, for example, it has a timestamp field, PID field, parent PID field, uh, name for the gadget, and all of this is also packaged as a config in the OCI image. And then you actually have the eBPF program, which you can just change it or modify it as per your needs. And if I peek into it, you can see that we have our own imports. So it helps you to kind of write the stuff easily. And then we also have different sections and also map definitions, and we use eBPF conventions for the section names, so that the programs, they can be attached by the loaders easily. So now that we have seen the program, what we'll do is that we'll try to build an OCI image from it. And to start this process, I'll first show that currently we don't have any image locally, and just like Docker, it follows the same pattern. So currently we don't have any image locally. I'll use the build command, pass it a tag just to name the image. And why I'm using localhost as a registry is because I want to showcase the entire process of the build, push, pull running from my machine, but it can be any remote registry. So I just run the build command. It actually compiles, create an alpha object, put that into an OCI layer, and then again you can tag it with different versions however you like it. And then I just also list the created image, and I just show that we have a Docker container running on my machine, a local registry where I can just push this my created image, and it's not so the IG command doesn't have any gadgets inherently now. So the built-in gadgets are there, but these image-based gadget, then they are part of the OCI registry now. So in order to publish the gadget that I just created, I'll just use the IG image push command. I'll copy the URL, the tag that I used, and then if you do that, you should be able to kind of just publish your gadget to an OCI registry. But in this case, I'll get an error because I'm trying to do it locally, which is insecure. So I'll have to pass in the insecure flag. This is kind of it also respects your registry credentials. So for example, if I was pushing to, let's just say, ACR or ECR with different private registries, it will also respect that. So I will just quickly showcase that you can also use this run command on a Kubernetes cluster, and for that, again, you have to have the gadget pods deployed like before, and then you can just use kubectl gadget run, and it will pull these images on all the nodes. And so this is kind of summarize the powerful way that now you can write eBPF programs, build them, push them to OCI registries, and if you want to do in a Kubernetes environment, you can just do kubectl gadget run. In this case of trace open, I'm running this trace open image, and then it has, like, for example, I can see all the events coming. And finally, if you like the project and if you're also interested in playing with eBPF, writing your own cool gadgets, we live on GitHub. You can use contributing.md as a great starting point. Look for issues with good first issue label. If you are curious to contribute, comment on them. We'll happy to guide you, and you can reach us out at Kubernetes Slack. And that's it. Thank you so much for listening.